Hello. Today we're gonna learn about object-oriented programming part 2. What we're gonna learn as following: printing objects, encapsulation, inheritance, and polymorphism. So actually in Python, when we want to print the information of the object, there's the method called string str. You need to have like two underscore before str and two underscore after str. And this method is useful for a string representation of the object. So instead of like calling the method to with some name to print the information of the object, we can simply just say print that object and define the string method so that Python interpreter will call string method and print the information of the object for us. So the string method is the one that should be the most human readable possible, yet also the descriptive of the exact object, like what we want the user to know about the object information. We can put that information in the string method. Okay, so let's see the example here. Here we have class person where we have any method that we initialize instant attributes name and age. And remember that or instant method we need to have cell as the first parameter. And here in the second method, we have display where the first parameter is cell, and we print the information of name and age, right? We are calling the attribute uh, name and age by printing as cell.name and cell.age. And please remember to convert age from into string by using string str method. On the other hand, when we define uh, underscore str underscore or string method here, in this method we want to return the string information of the object. So here we want to return name and the age of this person. And here at line number 13, we create the object with the name as Adam and age as 19. And when we call the method display, we get the information that Adam's age is 19. And at line 15, when we just simply uh, call the method print and specify the object name, we also get the same thing as we call the method display. Why? When we indicate that we want to print the object as we execute the code at line number 15, Python interpreter will call the method string. And when it call the method string at line number 9, it will return the string information that we specify in that string method. And that's as a result, when we say that we print the object, we will get the information that we return from the string method. Okay, so next, the topic that we want to learn is encapsulation. When working with class and dealing with sensitive data, we want to provide global access to all the variables used within the program. It's not a good choice because then there may be some bugs and there may be other people manipulate the value of the variable without telling other functions, or we don't know what's gonna happen, or whether there will be but the modification of that variable. So encapsulation offer a way for us to access the required variables without providing the program full-fledged access to any of those variables, so that some sensitive data or some variables that we don't want others to read or to modify cannot be accessed by other functions. So in an object-oriented Python program, you can restrict access to methods and variables, and this can prevent the data from being modified by accident. and is known as encapsulation. Data inside the object is not modified unexpectedly by external code in a completely different part of the program, so that this will also reduce the potential of having bug as well, because we don't want the value of the variable to change without our intention. uh, so typically when we define the instant attribute, those attributes are public members that are available to everyone. So anyone can read and anyone can modify. Right here in this example, when we have the attribute public member, right, uh, that we initialize in method init at line number 4, and then when we create the object of this class, and here we given the name with KKU, we can print it out as we indicate at line number 7. So that's why the first output is KKU, and we can also modify it at line number 8 and print the most recent value of public member. That's why we get GitHub at the second line of the output. So here, this also like the example of when we have public member name and age, right? And we can print it out, and we can also modify these public members. But in Python, we also have the choice of having an attribute as protected member. For protected members, protected members of a class can be accessed by other members within the class, and also are available to other to their subclass, but no other entity can access this member. Uh, Python has a unique convention to make a member protect by adding a prefix single underscore before the member name. So this the example. Here we have protected member where we have single underscore before the name. And here we can also print the value of protected member. On the other hand, if we want it to be more restrict, we can define the variables as private. So variable can be private, which can be useful on many occasions. A private variable can only be changed within the class method and not outside of the class. And objects can hold crucial data for application, and uh, if we don't want the data to be changed or modified from anywhere in the code, then we should have the variables as private variables. And the way that we define private variables are uh, by using a prefix with double underscore. So here, at line number 4, here we have private member where we have two underscore before the name. And outside this class, when we create the object of this class as m, and we print out the value of private variable at line number 7, and we can find that there's the attribute error here. The error message indicate that modifier object has no attribute private member because it cannot access private member here at line 7. So if we want to make the class member uh, method and variable private, we can prefix them with underscore. And uh, what if we want to access it with our intention? So here in Python, we have name mangling. Python perform name mangling on private attribute. Every member with a double underscore will be changed to object class variable. After the change, then that member can be accessed. So let's see the example here. So we cannot access m dot underscore underscore private, but we can access m dot underscore class name and then underscore underscore private member. So here, let's see another example here. Uh, Here we have name as public member, but has age as private member. And when we try to access the uh, private member directly, we cannot do that, right? That's the attribute error. So if we want to actually read the value of age, we should read uh, or print out the value via calling the method display, because in the method display it can access the private member, because method display is in the same class uh, in person, right? Display method is part of the class person, so that's why it can access private member of class person. And if we want to modify the variables, we can also uh, modify via the set method. So here we have max speed and speed as private members. And when we want to print out these private members, we can call the method drive. And when we want to modify max speed, we can call the method set max speed. And this another example. Usually here we have like private uh, member age, right? And if we want to read the private member, we usually define the method get underscore and then private attribute name. So here in this case, age is the private attribute, so we say get age. Observe that get age will return the value of age, so that's why here we return cell.age. And when we define instance method, please always specify cell as the first parameter. On the other hand, if we want to modify the private member, uh, we define the method setAge. So here setAge has cell as the first parameter and age as the second parameter. Here is the new value that we want to set uh, as the uh, new value for the age private member. And here when we display initially is 30, right? And then at line 17 we call method set age 35. And now when we display age again by calling the method display, now we see that the age is 35 as we uh, set the new value of the age. We are calling the set age method. So here we can observe that when we have a private uh, attribute, we can also have private method. And in class diagram, we can make the distinction between public method and private method via the symbol plus and minus. So if we see plus before the method name, that means it's public method. But if we see minus before the method name, that means it's private method. So for private method, it can only be called within the class itself. So here, we have update software as the private uh, method, right? Because we have underscore here. So in the ini method, we can call this private method update software. But at line number 14, we cannot call update software outside the class itself. So here we create the object red car, and red car we can call drive method of red car because it's the public method, but we cannot call the method update software of red card because it's private method. When we want to call that private method, we can see that there's the attribute error as uh, indicate at line 14 here. You say that car object has no attribute update software, but here is actually mean like update software is the uh, method, private method that we cannot call. So likewise, if we want to access private method, we also need to have underscore class name and then underscore uh, the private method name. Then we can call the private method outside the class. And here we cannot change private variable directly, but we can change via the ini method, right? Or via the setter method. So here we have max speed and name as private attribute, but in ini method, it actually initialize these two private attribute, and we can do that because ini is the method inside the class itself. So the next topic that we're gonna learn is inheritance. So inheritance is a way of arranging objects in a hierarchy from the most general to the most specific. An object which inherits from another object is considered to be a subtype of that object. And as we saw in the previous chapter, all objects in Python inherit from object. We can say that a string, an integer, or a person instance is an object instance. And we often say that a class is a subclass or child class of a class from which it inherits, or that the other class is superclass or parent class. We can refer to the most generic class as the base of a hierarchy as a base class. So why inheritance? Inheritance can help us to represent objects which have some difference and some similarities in the way they work. We can put all the functionality that the objects have in common in a base class, and they define one or more subclass with their own custom functionality. And inheritance is a way of reusing existing code easily, and that's actually the main reason why we learn about object-oriented programming, right? Because we want to reuse the code. We don't want to like duplicate code, or we don't want to rewrite the code that we have already written, or that code already exists. We already have a class which does almost what we want, right? We can create a subclass in which we partially override some of its behavior. We can add some new functionality. Okay, so let's see example here. Here we have class person, and class person has name, surname, and number, right? And we also have method description. And at line number 11 here, we have class student. And student is also a person, right? Student is a type of person. Not all persons are student, but all students are person. And here we also have divide student into two categories, undergraduate and postgraduate. And here in the ini method, we want to reuse the code ini of person, because here student is a subclass of person. We don't want to execute the code cell.name equal to name, cell.surname equal to surname inside the ini method in class student again. So what we do is at line number 17, we call super student cell ini and then star arguments, star keyword arguments. When we execute code at line number 17, then the Python interpreter will reuse all the code of the ini method of the superclass of student, and in this case is the ini method of person. So instead of having to write these three line of code, we can simply just execute one line of code at 17 to reuse the code of the init method in its superclass. And the additional code that we need to write in class student type equal to the given student type, and initialize classes as empty list. And here we also define a new method called enroll in class student. And in the method description, here we also want to reuse description of class person. So instead of execute the code that the same thing as description in class person, we can call super student cell dot description. When we do that, then if you reuse the code inside the description of its superclass or class person. Okay, here likewise we also have subclass staff member, which is a subclass of person. And in the init method of staff member, we also reuse the uh, init method of superclass of staff member, or reuse the init method of class person. And here we have can have many levels of inheritance. So lecturer is a subclass of staff member, and staff member is a subclass of person. Uh, a lecturer is a staff member, but not all staff member are lecturers. So here in the method, uh, we reuse the code of the in the method of staff member by calling the method super lecturer cell dot init star argument star keyword argument. But for the lecturer class itself in the init method, it also need to initialize clause taught as the empty list. And it also have a new method in its own class, which is assign teaching. And for description, it print out lecturer and call the description of the superclass, which is the description of staff member, and then print out the information of the course taught. Okay, so here when we create the object of these classes, here at line number 50, we create the object of student uh, who is postgraduate with name Jane, last name as Smith, and this the ID, right? And enroll PhD seminar one, and the description. So here when we print out the description, it will help print out that this object is student, and print out the ID, and also print out the course that are enrolled. On the other hand, we also create the object of staff who is lecturer, right? And this lecturer is name is Bob Jones, and course taught object-oriented programming. So here, let's see the explanation of this inheritance code. The base class is person, which represent like any person associated with a university. And remember that when we define class, we use uh, capitalized noun, or like we always start with an uppercase letter. And when we want to create a subclass, uh, to to indicate that this class is a subclass of another class, then we need to specify that subclass, and then parentheses, and then specify the superclass. So at line number 10 here, when we say class student parentheses person, that means student is a subclass of person. Likewise, at line number 27, staff member is a subclass of person, and lecturer is a subclass of staff member. And we represent both student numbers and staff number by a single attribute number, which we define the base class because it makes sense for us to treat them as a unified form of uh, identification for any person. So here we have name, surname, and number, right? And we also use different attributes for the kind of students. Here there are two kind of students, undergrad and postgrad. And we say when we assign these two variable which are constant variable equal to range 2. Range 2 mean 0 and 1, right? So that means undergraduate has the value as 0 and postgraduate has the value as 1. Likewise, for staff member, we have two types, permanent and temporary, and we also have this variable equal to range 2. And for the inhibitor, uh, in each subclass, we want the parent class attribute to be initialized as well. So we need to call parents inhibitor from uh, the vision inside the subclass, and we want to reuse. So that's why we call the inhibitor of the superclass. So here, let's see the uh, class student here, which is subclass of person. And in the ini method, we need to specify cell as the first parameter and student type and star argument, star keyword argument. Star argument here will match with the argument that we define in the ini method of class person. So star argument here will cover parameter name, surname, and number because star argument can be any number of arguments. And here in the ini method of class student, then we assign student type equal to the given parameter and cell dot class as empty list. And at line number 15, when we specify as super student cell in the star argument star keyword argument, this will call the ini method of the superclass of student, and the superclass of student is person. So it will go to call the method ini of class person, and that's how we reuse the code of the superclass. And common convention is to add the specific parameter for each successive subclass at the beginning of the parameter list and then define all other parameters using star argument and star keyword argument. So that's why we see here cell student type star argument star keyword argument. And star argument here will cover name, surname, number of the parameters of the superclass of the ini method of superclass here. So subclass doesn't need to know the details about the parent class parameters. And there are different forms of inheritance. Single inheritance, which is when a child class inherit from only one parent class is is called as a single inheritance. And multiple inheritance where a child inherit from multiple parent class. Unlike Java and like C++, Python support multiple inheritance. So we specify our parent class as a common separated list of bracket. Multiple inheritance mean one object can have many superclass.